Net present value, or NPV. The net present value method is the capital budgeting method for analyzing potential investment projects that asks the following key question. And the question is, does the investment make at least a specific percentage return, yes or no? In most cases, a company will identify a certain level of percentage annual return on its investment that is appropriate, or that's a target to try to be reached. And net present value tells you whether or not the project will generate that much of a return. The way that it does it is you take all of the future cash flows that will result from the project. So let's say you make an investment and it's going to create these additional cash flows in the future. You figure out how much those are all worth today in the present based on the percent return you're told that you have to earn. And you compare that to the original cost of the investment. And if the amount of the present values of all of those future cash flows, if that were exactly equal to the original investment, then you would say that it earned exactly the percent return that you were trying to earn. If it were higher, or if the present value amounts that you came up with were higher than the investment, and you figure that out by comparing them, subtract the investment amount from the present values, then that means that you earned more than your target percentage. So if your company was saying we got to earn 15%, and you discount all the future cash flows backwards at 15% and add them up, and if the amount is higher than the original investment, then you could say you earned at least 15%, and in fact you probably earned higher, and that's an acceptable investment. The interest rate that we use to discount these future cash flows back to present values is called the cost of capital, and it has several other names as well, like hurdle rate, required rate of return, different names like that. This is an example of a net present value. We have an investment here that costs $1,000, and it's going to yield, we estimate it's going to yield future cash flows in year 1 of $500, cash flows in year 2 of $500, and cash flows in year 3 of $500. Our company says we have to earn at least 9% return, otherwise we're not comfortable making this investment. So you'll see here that what we did was we discounted each of these cash flows at 9% back to the present, and we added them all up. And they total $1,265 for all 3 of those cash flows. We compare that to the initial investment, which was $1,000. And it turns out that these present values were higher by a total of $265. We did that by subtracting the initial investment from the present values. We call this a positive net present value. And what it means is we earned at least this 9%. In fact, because this number is positive, we earned more than 9% return. Now, do we know exactly what percent return we earned? No, not yet, and that's a separate calculation. But we do know that we earned at least 9%. In fact, we probably earned more because this number is higher than 0. So this represents an acceptable investment under the net present value method. And remember, the question we asked was, does this investment of $1,000, does it earn at least a 9% return? Well, by discounting each of these backwards at 9% and adding them up, they total $1,265. We subtract the original $1,000. We're left with something that tells us, yes, it does earn at least that minimum 9% return. And so we call this a positive net present value and an acceptable investment. If the net present value were negative, that tells us that the future cash flows do not represent, in the last example, at least a 9% return, or whatever the target return was for the company. So this is an important thing to understand, is that if net present value is negative, it usually means that the project is not acceptable. And if it's 0 or positive, then it means that the project at least returns the minimum required percentage return that we were looking for as a company. If you're going to do this with a calculator, most calculators have what they call a cash flow function. You will need to refer to your calculator's user manual to make sure that you know how to input the numbers. And generally, you just put in all the cash flows, tell it what the cost of capital or the targeted rate of return was, and solve for net present value, and it will give you a number. You can do this in Excel as well, so let's take a look how to do this in a spreadsheet. So what we have here is a possible investment that costs $100,000. And the first thing that you'll notice is that we formatted this as a negative number. When we do cash flow analysis with capital budgeting projects, we generally will put the investment amount as a negative number, and we call this period zero or year zero. You'll notice for this investment we have a series of cash flows that will come back to the company throughout the next 5 years, and that they are uneven. So $25,000 in year 1, $35,000 in year 2, and so on. You also notice here the company has identified that they want to earn at least 12% return on this investment. So the question is, do these cash flows here represent at least a 12% return on this investment of $100,000? Yes or no? We know that if we get a net present value that's 0 or higher than 0, that we earned at least 12%. We also know that if the net present value comes out to be a negative number in this case, that we did not earn at least 12%. What we're going to use to calculate this is something called the NPV function, but I need to qualify this by indicating that we will need to make a minor correction to the NPV function in Excel because it does not work exactly as it is supposed to. So I'll bring up the NPV function. NPV is its name. And it's asking us for a couple of things. First, it's asking us for an interest rate. And that rate is up here. That's the cost of capital, or the rate of return that we are trying to at least meet or exceed with this investment. Where it asks for values, what we're going to do is, rather than selecting all of the cash flows, including the investment amount, we're just going to select these future cash flows here. And then we're going to manually subtract the investment amount to see whether or not we have a positive net present value. So I'll go ahead and hit enter. This tells us that the total present value for all of these cash flows here is $134,000. We want to know whether that's higher or lower than the investment amount, and the way that we do that is by subtracting the investment amount. Since the investment amount is already entered as a negative number, I will actually add then whatever is in this cell. So I'll go up here and modify this and say plus whatever is in cell A7, because that has been entered as a negative number. So it's going to subtract the original $100,000 investment, and we'll see what we're left over with. We're left with a positive net present value in this case of $34,270, which tells us that yes, we earned at least 12% on the investment. Now, do we know what the exact percentage was that we earned on the investment? No, we do not know that just yet. But we do know that we earned at least 12% because this number is positive. So let's take this opportunity and have you attempt a net present value problem. Here is one where the investment is $10,000. You'll want to, whether you're using a calculator or a spreadsheet, you'll want to format that cash flow of $10,000 as a negative number. We have a cost of capital, or a targeted hurdle rate, that we're trying to beat of 11% per year. And the cash flows are as you see them here on the screen. If you input all these cash flows and you use the net present value function, you should wind up with a positive net present value of $850, which you see the answer there at the bottom of your screen. Go ahead and give that a try, and then press continue when you're ready. Here is another sample problem for you to attempt. This one has an initial investment of $45,000, which we should format as a negative number. We then have cash flows in years 1 through 5 identified here on the screen, and a cost of capital of 10%. The answer is on the bottom of the screen. Please give this a try and see if you come up with the correct answer.